Hey everyone, it's That Math Magician, and on this video we're going to close out our series of videos on angle relationships. Let's go ahead and do a quick recap of the 4 angles that we have learned so far. We first started with complementary angles, which add up to 90 degrees, supplementary angles, which add up to 180 degrees. We then focused on vertical angles that occur when you have intersecting lines, and we said that the opposite angles are always going to be equal. In our last video, we looked at corresponding angles, which occurs when you have 2 parallel lines. Those lines have to be parallel. You have your transversal cutting that line. And we said corresponding angles were angles in the same position, just at different intersections, and that they're always equal. So on this last video, we're gonna focus on our final 2 angle relationships. For that, I'm going to borrow this diagram that we did in the last video, and what I'm gonna do is I'm going to copy that so that I'm able to use it for our 5th and 6th angle relationship. So let's go ahead and write those out first. Our 5th angle relationship is called alternate interior angles. Okay, and then our 6th one, which I'm also going to write right next to it, just so that we have them at the top and we can talk about both of them. The 6th angle relationship is called same side interior angles. So let's go ahead and paste that diagram from our last problem so that we can talk about these 2 angle relationships. Now, alternate interior angles, same side interior angles. Again, this is only going to occur when you have 2 parallel lines getting cut by a 3rd line that we're calling the transversal. Let's go ahead and focus on the alternate interior angles. Now, alternate interior angles, they are angles that are going to switch sides. Okay, they're going to switch sides of that transversal line, and they're going to end up being equal. Let's write that out. Alternate interior angles, they are angles on opposite sides of the transversal inside the parallel lines they are equal. Now, 2 big vocab words in the title: alternate and interior. Interior means that we're going to be thinking about the inside portion of the parallel lines. I could go ahead and get my highlighter and show you. When we're talking about interior angles here, we're talking about the space inside the parallel lines. We are not referring to angles A and B or G and H. Those would be exterior angles. We're only focusing on the interior angles. Now, our definition says angles that are on opposite sides of the transversal. So do we see here that I have angle E here? As I'm sliding up my transversal to look at the angles at the top, do we see that when I look up here from E, that angle D and E are equal? We knew that from the last problem, but the name that we're going to refer to them now is alternate interior angles. So, angle E is equal to angle D, not just because of what we just focused on, but we're calling them alternate interior angles because they're both inside the parallel lines but they're on the opposite side of the line. So E and D are alternate interior. They are equal. We can now say the same about angle F and angle C. Because they both live inside the parallel lines and they're on alternate sides, those angles will always be equal. That is what alternate interior angles are. If we know right here that, let's say E was, 120 degrees, we now would know that D is also 120 degrees because of alternate interior angles. They are always going to be equal. Alrighty, that's our fifth one. Let's go ahead and jump over here to our sixth one, which is called same side interior angles. Now, for same side interior angles, very similar to what we just talked about with alternate interior, but this time instead of looking at the angle that's on the opposite side, we're going to look at the angle that's on the same side. So let's go ahead and write out our definition for same side interior angles. They are angles on the same side of the transversal inside the parallel lines. And what same side interior angles are, let's take a second before I write down the last piece. As we're looking here at this diagram, we would call E and C, angle E and angle C, they would be same side interior angles. They are on the same side of the transversal, they're inside, but they are not highlighted the same color. We know that they are not equal, but in fact, E and C are supplementary angles. They add up to 180 degrees because remember, C and G were equal, right? They were corresponding angles. And we already knew that E and G made 180 degrees. These two angles are supplementary. They form the green transversal line. They add to 180 degrees. Well, if E plus G made 180 degrees, then E plus C will also make 180 degrees because G and C were corresponding. So, same side interior angles, they are not equal. Instead, they are supplementary and they add to 180 degrees. Let's go ahead and finish our definition. Angles on the same side of the transversal inside the parallel lines add to 180 degrees. I'll put in parentheses, they are supplementary. Looking at that diagram, let's see if you can figure out the other two angles that are also same side interior angles. We took care of E and C. The other pair of angles that are same side interior would be F and D. So we also know that angle F plus angle D will also give us 180 degrees. Okay, everyone, those are the final two angle relationships that we're going to be looking at. We have alternate interior angles, we have same side interior angles. These facts will always hold true. Alternate interior, they're equal. Same side interior, they're supplementary. They add to 180. All right, guys, it's that Math Magician, and I'll see you on the next video.